We have been talking about ILM, Interface Logic Model, that can be used for the hierarchical approach synthesis for the large and complex design. Now the question arises, what exactly is an ILM? It is nothing but a design representation using the netlist, physical information, constraints, spef, which are associated and related to the interface available for that particular module. So, this ILM represents the logic associated with the inputs and outputs of that particular design. And the information included with the ILMs is accurate, and they can be used for the chip-level analysis in the hierarchical design. If you talk about the interface logic, what all it contains the circuitry from input-output ports to the edge-triggered register, which is called interface register. Now let's check out why we should go with ILM flow for our hierarchical synthesis. What is the motive behind that? Even though we have the .lib extraction for the sub-design that can be used easily at the top level, what is the reason for using the ILM flow? Let's take this simple example. You have partitions A, B, C, D, which are hard module E soft, that is, it can be in RTL form. And then you have the glue logic. You can use the complete partitions of A, B, C, D. In that case, E can be optimized, and glue logic can also be optimized. With that, A, B, C, D modules can be preserved. So, with such a scenario, you can use the ILM-based method to do the top-level optimization very effectively. And by that, you also have a faster runtime even on the large design sizes. Let's check out the benefits of using and having the ILM model in the design. The ILM model represents the original design's accurate representation, as we have seen the constraint extracted from the original design. They do not abstract, and they discard what is not required for modeling boundary timing. They have a small memory footprint and runtime, and up to 90% of the logic can be discarded. It can be adapted easily at any stage of the design process like pre-place, pre-CTS, post-CTS, or post-route. Also, it is easy to debug because the interface logic is maintained. Say, if you are having differences in a timing characteristic of the ILM. So, it can be easily debugged. Also, it is easy to replace one ILM with another. Model generation runtime using ILM is also fast.